All right. Well, yeah, my name is Mark Boardman. I'm really pleased to speak to you um, uh, about climate change. Uh, Climate change is one of my two important kind of public interests at this point, since I'm now retired. The other is land conservation, conservation in general. I work with Three Valley Conservation Trust pretty heavily. And so I'm really pleased to talk to you about that as a representative of Three Valley Conservation Trust to the activities that Oxford is doing to prepare us for climate change. And let's see if I can, let's see. Does that show up large now? Good enough, good enough. Several years ago, citizens got together and thought that climate change was an issue and wanted to do something to improve our chances in the future, improve our livelihood in the future. And they got the city to approve a value vision statement by city council. And after that, city council formed a task force that came about, got information together from stakeholders such as you. I became involved at that point with the task force. Recommendations to the city council were made. City council did their magic, review, report, readings, and eventually in 2019 had a resolution to commit to a multi-year process. The resolution was to commit to the Global Covenant of Mayors for Climate and Energy. And part of that commitment was to form a committee that would review and assess what the city of Oxford was doing and to plan, assess kind of vulnerabilities, issues that might be a problem in the future, and come up with a plan to recommend to the city, and then to provide a method for monitoring that as well. So the first thing that committee was trying to figure out was just how serious is this issue? And the first thing that we need to know is this really a serious issue for Oxford in particular. Globally, it is a serious issue. I can't. Oops, I can't, I lost it here. And the first thing to look at globally is that the ground level temperature is significantly increasing. It has been for several years. And by significant, it just a few degrees, just a degree, just two maybe degrees. I'm going to see if I can get back in, because I can't see the whole image. I'm not sure if you can. That might be better. And that's been going on, and we're now about a degree or two above what we had been in the 1960s. This is the ground temperatures, and the ground temperatures come about from, now I can't get to the next one. Ooh. Yeah, I don't know why, it's too bad. From stations such as this, Miami University has a station, and there are many of these stations in the world. In the United States, there are hundreds, and even there are thousands of stations like this. I show this slide to let you know that the data, that we have on the ground temperature is extraordinarily robust. It's not a few weathermen doing part-time work, but this is an extraordinarily robust network, which is run by the agencies such as NOAA, the Weather Service. And it's not just in the United States. This is an older picture, but throughout the world, there are many, many stations, thousands and tens of thousands of stations recording temperature. And what they've come up with over the last 100 years or so is that the temperature seems to be increasing at every, on balance, every month of every year. In the 1880s, it's shown here in blue, and then in green, and then finally in up until the late 2010s, 20-teens in red. It shows no sign of decreasing. Every month of the year, the temperature seems to be increasing. We also know some other information about climate, about temperature, and that is that it's not just in the at ground level, 5 feet high. That's what the official ground level temperature level is. But in the lower atmosphere, from ground level up to where airplanes fly, 40,000 feet, the temperature has been rising since the 1960s when we have good data in there. And that's the lower atmosphere. In fact, we also have data from the upper atmosphere from 7 miles high up to 30 miles high. That, in fact, for some reason, that part of the world is cooling, which is maybe a shock to some people that the upper atmosphere is cooling, but it is. We get this data together, and it looks like the lower atmosphere is warming, the upper atmosphere is cooling. The explanation for it is that the heat that used to warm the upper atmosphere is now being trapped in the lower atmosphere. So the upper atmosphere is not getting the same heat that it used to get, and the lower atmosphere is getting more, is kind of keeping more of its heat because of its blanket of carbon dioxide mainly, but other greenhouse gases. What that means is that warm, moist air as it rises is going to encounter colder air more quickly. We might expect, and I think we're seeing, more violent storms occurring. It also means that the lower atmosphere is going to is going to cause increased evaporation. So we might expect more droughts there. So what we end up with are increasingly more droughts on the surface and more intense rainfalls when it does rain in our Earth. So that's a pretty serious thing. We have a pretty good idea that this temperature situation in the atmosphere is pretty good. Every day, twice a day, balloons are launched with a temperature sensor on them from 900 places worldwide. So we have this they go up at 7 o'clock local time every day, and then at 7 o'clock at night as well. So this is kind of the source of the data. It's pretty robust. It turns out, though, that most of the heat that is coming about that we should be worried about, if we worry about things like this, is in the oceans. And we've never had really good idea of what the ocean temperature was until fairly recently. In the 60s and 70s and 80s, we had ships that would go out and they would measure ocean temperature. They would sometimes lower things off the boat down to depths of 100 meters, 700 meters, 1,000 meters. But it was really difficult to get good data until about 2005, 2008. We started putting floats out, and they would float around. Sometimes we would design them to sink for a while and then come back up to the surface and send their information back to us by radio. And so we've kind of moved away from having to go to buoys and having ships. And we've moved toward this idea where we just have a ship, we just throw a buoy or a float out. The float is designed to sink to several thousand meters and then designed to rise again on its own. When it gets to the surface, it sends its information back and tells us what the temperature has been in the ocean. And we started this in 2001. We had about 179 floats. We put them out where we could. And then since then, we've gotten some more in there. And these are the pictures of where we've put these floats out. The floats last about 10 years before they kind of run out of battery juice. They can be, if they're found, they can be reconditioned and improved. So we're up to 2008 now, where we've got these things. So we've had some pretty good data for the last 10 years. We're at 2011, and we're up to about 3,500 buoys or floats. There we're just about to pass 4,000. We just passed 4,000 floats in 2016. This is your and my tax dollars at work. I hope we appreciate it. All this money coming out. It is an international venture. So that today we have over 4,000 floats in service, and they are constantly reporting back to us this information. So we have a really good idea of the temperature of the ocean. We have an extraordinarily good idea of the temperature of the surface of the Earth, and we have an excellent idea of the temperature of the atmosphere. So we're in really good shape in terms of having the data to say that, to kind of let us know how the Earth's temperature is changing in a variety of ways. The thing is that these changes in temperature at the surface, in the atmosphere, in the oceans, they trigger other things. They'll trigger the melting of the polar ice. And when the polar ice melts, it gets darker. When it gets darker, it absorbs more sunlight. When it absorbs more sunlight, instead of reflecting it, it gets warmer yet. If it gets warmer yet, it will melt even more of the ice. So there are some consequences, some connected effects that affect a variety of things. One of them being weather. This overall increase is going to trigger changes in where we have droughts and the intensity of droughts and floods and fires. Biologically, they are a almost unknown. We can see things happening, but predicting, bird migrations or monarch butterfly migrations, these are really, really tough to do. But they are all really connected, very much like our domino idea, where you start one thing and it just another thing happens, and the effect is maybe unrelated, or you think it's unrelated to the original global warming part that was there. In fact, sometimes a small event is just that we can reach a kind of a small triggering event. And then I wanted to show this video.
Ready? Boom.
Amazing.
That was 13 dominoes. If I had 29 dominoes, the last domino would be as tall as the Empire State Building.
Well, that's a lot to have, but this thing is that it's very much an issue, climate change. And one of the questions that we have is, what can Oxford expect there? We know that global warming is occurring. What does Oxford expect? And it's true that Oxford can expect a longer growing season. And this could be fun. This could be very fun, but it also means a longer allergy season. So that's not necessarily what we want. We can expect by 2060 or 2050 that our pollen level will be 2 or 3 times higher than what it's been. So if pollen is an issue for you, it is for me, then maybe that's something we want to worry about. How about days above 90 degrees Fahrenheit in Oxford? This is data that we got from the Weather Service. How many days of the year does the temperature in Oxford get above 90 degrees? And there were a few years where it was very often above it, and a few years, 1990, looks like 1993 was a year when it didn't get much above. But it's how many, what can we predict? Predictions are that the number of days when the temperature is above 90 degrees is going to increase. In the 2020, it's about 20 days. In 2025, we expect about 35 days. By 2035, we expect 50 days where the temperature will reach 90 degrees or better. And then after that, I care about it, but after that, it gets worse and worse. And the question that we asked ourselves, can we really prepare for this? What implications, what linked implications will occur? How about 95 degrees? We don't get many of those. Typically, we get 5 to 8 of those per year where it reaches 95. In 2025, we expect 10 or better. In 2035, we expect 15 days of the year. It'll all be during the summer, of course, where it'll be pretty darn warm there. And not just the days. The nights are going to get warmer as well. So we won't even have a nice cool down all the time in it. So this is going to put a real stretch on our electricity to heat, and there's a comparable one for cooling. There is something called a cooling degree day, and it's not a day. I've tried to figure out a better number. This is what Butler Rural Electric and Duke Power used to estimate how much energy is needed to keep us cool, and it looks like it's gone up a little bit. Those numbers, they're not days, sadly, but it looks like by about 2040 we will have twice the requirement for cooling than we do right now. And so this is going to be an issue. If we think rolling blackouts or brownouts are difficult now, we will have twice the problem in another 20 years. And that's something that we might ask ourselves, is there anything we can do at all to that? Do we have a secure power distribution? All of our energy comes from central sources. Maybe that's a mistake. Maybe we should have more distributed power. Maybe we ought to really start thinking about cutting our need for power down. Maybe we ought to start moving towards some other way. We've got some time, and so I think overall we want to take that time to do something. Also, there's predictions rainfall. We expect the rainfall to increase a little bit here from about 40 up to 41, 42 inches per year. The question we have to ask ourselves is, will the rainfall always occur at the same time? Or will most of this rainfall start to occur in intense storms in the spring, leaving our June, July, August, September with no water coming down? I've been here, and I know most of you have been here when we've had water shortages in Oxford, and we solved that by going to a neighboring valley, and we tap into their water source. And now we have a single pipe that pipes water. Maybe we need a second pipe to that. Maybe we ought to think about new ways to control our water, because it looks like there's going to be a lot more heat to worry about, and we're not quite sure what the distribution of that will be. So there are quite a few things that we need to think about that may happen. Windstorms. I was here during Ike. Most of you were too when the electric outage went. Should we bury the utility lines? Are windstorms going to be an issue in the future? Are we going to get the remnant of a hurricane coming up here every 2 years instead of every 50 years or something? And what about snowstorms? We don't get big snowstorms anymore, but we don't really, we got to look into it. I guess just let's not be stupid about this. Let's try to look at what might be coming up in the future. And so we can ask ourselves, what are we actually doing? What is Oxford doing to meet this? And the good news is that in fact, Oxford is doing what it normally does. It has created a committee to evaluate this. I happen to be on that committee to evaluate the potential risks and the vulnerabilities. And then the committee will make a recommendation on it. We're doing this because we don't see that the leadership at the state level or the county level or the federal level is specific enough for us, is adequate maybe for us. Maybe there's something we can do right now to prepare ourselves for 10, 15, 20 years. And I don't want to wait. I'm not sure, I don't know anybody who particularly wants to wait for the government to do something for me. I'd rather, locally, I think we really can do something. So your cities, our city, City of Oxford, did finally join something called the Global Covenant of Mayors. This was 2 years ago. And it is a commitment. It is a toothless, aspirational commitment to address potential mitigation and adaptation processes. We need to know where we are in terms of what our dependencies are on different energy sources. And we need to prepare for potential climate change impacts. And then we need to track our progress. How are we doing? Yeah, there is this target. We hope that we can do things that will reduce our impact on the increase in temperature. But frankly, I have as much I'm very concerned about my power, my heat, my transportation, my grocery store's ability to get food. I mean, these are things that are going to affect me. If there's anything that we can do locally to improve that sustainability, I'd like to do it. So the Global Covenant of Mayors is a roadmap, and that's what it's designed to do. The committee that was set up has Jessica Green as a non-voting member, but probably one of the most important influential people. It's got a bunch of citizens in there, listed there. And then we work with the Miami University IES program. They have student projects there. This is all volunteers, except for Jessica and probably Adam Sizemore from Miami University, who is on it as well. We have the roadmap is that within a year, we will come up with an inventory of what climate-related activities might we be concerned about, and then specifically what some of the risks and vulnerabilities are. I've mentioned one. I think sustainable electrical power is one, but there will be others as well. Water might be one. We might, there might be some other, issues that have to be addressed. And so we have this Oxford Climate Action Steering Committee. It's a mouthful. It's an advisory committee. It has no regulatory issues. It is aligned with the city's goals. The city has 3 principal goals for this coming year, and a bunch of other goals. One of them is that environmental sustainability, and we are a part of that goal. So from citizens' concerns to the vision, to the recommendation, to a resolution, to a committee to do this, we will interact with the existing boards within the city, staff, commissions, council, civic groups such as yours, and combine that with citizens' input. And the plan now is to try to weave climate resilience into the next comprehensive plan. The next comprehensive plan will be prepared in the next few years. And this will be a combined effort that should have a lot of input. It's going to need a lot of input from Chamber of Commerce, from civic groups, from Rotary. We're going to need people to step up and make sure that your concerns are put forth and addressed. As any political situation, there will be pluses and minuses, but we really want to make the best decisions we can on this. And one of them is to make us as resilient to the next 10, 20, 30 years of climate change that we can. It's a serious issue. I think there will be some serious issues. You can already think about what we're going to do with the with transportation around here. Do we continue to want gasoline-driven cars? What do we do with the electric cars that are coming on board? What about housing? What about building models? I'm glad that my roof recently had 12 inches of insulation added. That's a resiliency thing, I think. Houses now, maybe they should have 6-inch walls or 8-inch walls. That's a resilience thing for the future. And the good thing about this is it's, we've got some time to start acting. We're in the planning stage. It's going to be exciting. I think in the next several years. I'm excited to be a part of making some suggestions, and we'll see what it is. In Oxford, we worked as a committee, the Oxford City and students at Miami, and it is a community, and we're all involved. So that's what I had to say. Get ready for buckle up. I think we're in for some interesting next few years. That's what I had to say. Thank you.
Thank you very much, Mark. Are there questions for Dr. Boardman? Anyone?
Not necessarily a question, but a comment. Dr. Boardman, thank you so much for coming and sharing today. Really appreciated this presentation today and your previous presentation about Oxford, past, present, and in the future was just very, very good. And we were able to record that and share that out in different ways and got a lot of good feedback. So I don't know if you've seen that in any way, shape, or form on social media, but just wanted to share that with you, that a lot of people enjoyed that.
Well, thank you for that comment. I think groups like Rotary are the leaders of the community, and so you're the ones who are going to be, I think, most influential in guiding Oxford to a really livable and sustainable destination in the future, and that's really what I hope to be part of.
Mark, Bill Pratt.
Yeah.
Do you think the efforts the government is making here and other countries to reduce air pollution is really effective. It's a way of dealing with this that we'll be glad we did.
I think it's one measure, and I think it's the best that we've got right now. The next steps are going to be kind of life-changing steps that will be, in terms of quality of life, are going to be more costly. I think a lot of the air pollution is by automobiles, and changing that to something else is going to be a wrenching experience, I think, for many of us. It's likely we'll have all electric cars in the next 20 years, but the gasoline cars are going to be phased out. That'll probably happen just because it'll be cheaper to run them. It's likely most of our power will be by alternative energy sources in 20 or 30 years because it's just cheaper. It's going to be cheaper. But during that time, there's going to be some changes that will be hard.
And are you saying things are going to get worse rather than better? No matter.
I think they're going to, I mean, in my life right now, any change is worse. I mean, any change that happens is worse, almost. Will we get used to a more costly food? Will we get used to a different kind of not the typical plastic, but a different kind of plastic, a different plastic? I think we just need to get used to different things, and all of them are going to be resisted by there's going to be a lot of resistance, and I think we have to just step back and give things a chance. So I think in the short run, everything is going to be a little bit difficult. Right now, we have twin 5-year-olds, and every change is just seems to be tears. Go to bed now. Oops, I can't do that. So I think for many of us, maybe all of us, these changes are going to come hard.
You seem to be saying that no matter what we do, it will get worse. Right?
Well, as far as climate change,
yes.
Oh, hands down. It's not even. It's kind of a wasted argument to talk that it's going to get better. No, what we can do is adapt. I mean, that's why we're not the strongest animal in the world. We're the most adaptable one in the world. So we can adapt and change. And so that's what we have to do. We have to be flexible. We have to, look this square in the eye and say, yeah, we can make a difference.
Mark, this is Lee Fisher.
Yeah.
With alternative energy sources, how do you marry the problem that the wind turbines faced in Texas with bitter cold when they froze up and stopped? And does that make wind technology less of an option going forward?
I think it does add a challenge to wind energy. I think a bigger challenge is having a single large distribution center for energy anywhere under any circumstances. The wires that are bringing the electricity to our homes, I think, are the most fragile part of it. That distribution system is something we really have to look at carefully. So wind and any energy source is going to have a problem with it. We need better storage of energy. So wind energy works only when there's wind, solar only when it's sunny. So we certainly need better storage of it. The biggest storehouse of heat that we have is the ground. I would be one, and this is me personally, I would be one to ask the building code to be changed so that there are only geothermal units installed for housing, for heating in the future. Now, I don't know, that's an expense and it's going to be resisted. And I have no illusion that it will be accepted as a recommendation, but that would be my recommendation, that we should move to geothermal, for the use of geothermal energy, supplemented by a solar wind generation, which is closer to Oxford. I think Oxford should have its own kind of energy producing areas closer, because I don't want to depend on Cincinnati or Dayton to deliver the energy to me. And that's what we do now. And with these big wires, I'm not sure. I'd also recommend personally that any new subdivision, anything, bury your utility lines, you know, and get ready, bury them. Because I don't think we can expect the utility lines and the poles to be as resilient to windstorms as burying them. So there are some things we can do. To pick
Mark,
on any one is difficult.
With your, what you just said about adapting the code to geothermal, but you didn't mention anything, and I know you know this, about the $50,000 to $100,000 cost to put a geothermal unit in.
You know, that was one, and I certainly, that certainly is the issue. That's why when we got new heating in our house 15 years ago, we did not go geothermal. We couldn't afford it. It was too expensive. And I think that is an issue. If I had it to do now, I'd seriously consider that's a good option. I'd give it more careful consideration now for it. And it is expensive.
Mark, in terms of the city's committee, is there an issue relative to population shift as a result of climate change?
Well, as I mentioned in the last time I talked here, we can expect about 50 million people to be physically displaced because of coastal flooding along the coastal areas, and their houses will no longer be habitable. They will be physically displaced. Other places like in Phoenix and New Orleans, I think, will be temperature and humidity displaced. The expectation is that the migration over the next 20 or 30 years will be 5 times greater than the migration during the 1910s, 20s, 30s up into this area from the south. We can expect a huge migration. It's going to change the surrounding population areas. What it will do to Oxford itself, I don't know. Most of that migration will be to larger cities. Detroit might be the next biggest city in the world, for all we know, as people move back to Detroit. Our neck of the woods is going to be one of the more comfortable places to live, one of the places that has a more steady supply of water, a more equitable temperature. We will be a desirable location for people to come to. And what that will do to Oxford in particular, you know, I don't know. I would hate for Oxford to begin to put up walls to keep these climate displaced people from coming. They probably won't be the wealthiest people coming. They'll probably be people who have been displaced and are going to come up crying up here for jobs, looking for someplace to live. That's a social issue that is a real issue, I think, Dennis.
Are there other questions for Mark? Seeing none, Mark, we certainly appreciate your input and discussion today.
I really want your input when it comes to the comprehensive plan. We need to know, and we need to be clear. More eyes, the better.
Great. And we will be putting a book in Wayne Library in recognition of your presentation today. Sorry we had some technical issues, but
Me
we're
too.
glad you were able to join us.
Me too. Thank
You're
you.
certainly welcome to stay on. We've got just a little more business to conduct.